has good electrical and thermal conductivity.
Okay, so that's hard, shiny, malleable, which means it can be bent into a shape without breaking, fusible, which means it can be fused together, oftentimes by welding, and ductile, which means it can be put into a long wire.
It also has good electrical and thermal conductivity, which means it's great at transferring heat and electricity. Let's take a look at this at the molecular level, shall we?
In pure metals, the atoms are arranged in orderly rows and columns. Each atom gives up some of its electrons to create a kind of sea of these randomly moving charged particles. It's these free-flowing electrons that make metals conductive. When placed in a circuit, the negatively charged particles line up and flow as an electric current.
So that means if you hold one end of a long piece of metal and put the other end overheat, you'll eventually feel the heat on your hand where you're holding, even though it is not in the heat source. How cool is that?
Metals can be organized into different groups according to their physical and chemical properties. This can be clearly seen on the periodic table. Why don't I show you? That's better. First we're going to talk about alkali metals.
Now we're going to talk about alkaline metals.
Transition metals.
Go.
Other metals. And metalloids.